we're going to connect confidence intervals and significance tests and see how the diagrams can help us compare the two and how alpha level is connected to significance level. So with a 90% confidence, we're going to connect this to an alternate hypothesis using does not equal. So either the proportion does not equal or mu does not equal. So 90% confidence means we've got 90% in the middle, and then between the two tails, we'd have 5% in each of the tails, the lower tail and the upper tail. Now, in a significance test, this would be centered around the null hypothesis, and we'd call this a two-tailed test. That's because we use the does not equal in the alternate hypothesis. So we would leave 5% in each tail, which would total to a 10% alpha. Now let's look at an 80% confidence level. So with 80% confidence and an alternate hypothesis that says, for example, P is greater than or mu is greater than, we would only shade 10% in that upper tail, but we have to put an equivalent of 10% in that lower tail. So alpha here is only 10% because it's a one-tailed test, only the upper tail based on how we wrote the alternate hypothesis. The next example, we're actually going to start with the alpha level. The alpha level here is 5%, and we're again working with a two-tailed test because our alternate hypothesis says P does not equal or mu does not equal. Well, if it's 5% significance, we have to split that 5%, 2.5% in the lower tail, 2.5% has to be in the upper tail, so it totals to 5%. In a two-tailed test, you have to split alpha. That means the middle would be 95% confidence interval. Now let's look at a one-tailed test. Okay, so alpha is 1%, and say our alternate hypothesis says that P is less than or mu is less than. That means our 1% is all going to go in that lower tail. But if I'm connecting this to a confidence interval, I'm going to have to balance that lower tail with the upper tail to keep symmetry. So I'm also going to put 1% in that upper tail. So I have 1% on the lower tail, 1% in the upper tail, meaning I've got 98% in the middle, which is why this is the same as a 98% confidence interval. Let's try some examples here. So in this problem, I have a 96% confidence level. I'm told I'm going to have, I'm trying to find the alpha level, and it's a two-sided hypothesis test. So I'm going to sketch my diagram, normal curve, and I'm going to label what I know. If the confidence level is 96%, that's my middle interval, which means I'm going to have 2% in the lower tail and 2% in the upper tail. Okay, so if I've got 2% shaded in the lower tail and then 2% shaded in the upper tail, that gives me a total alpha level, because this was a two-tailed test, a total alpha level of 4%. And so a 96% confidence interval and a two-sided test is equivalent to an alpha of 4%. Now let's look at the next example where we have a significance test where it's a one-tailed test because it says mu is greater than 3. It's just one-tailed, but the alpha is 15%. So on my diagram, I'm going to shade my alpha level. It's on the upper tail because my alternate hypothesis used the greater than sign. So I shade in T star and above, and that's 15%. Well, if I'm connecting this to a confidence interval, I have to shade the equivalent amount, so a negative T star, on the lower tail. That has to also be a shaded area of 15%. So if that is 15% in the lower tail, and the upper tail is 15%, that's a total of 30% in those tails, giving us an interval in the middle of 70% of all of our data. So a one-tailed 15% confidence interval is one-tailed 15% alpha level is connected to 70% confidence level. Here in this last example here, we're given some information and we're asked to calculate the p-value of the test. I'm going to need to know my degrees of freedom, that's n-1, and I'm also going to have to use my calculator in order to find the area under the curve that is below a t of negative 1.12 with 24 degrees of freedom. But since this is a two-tailed test, I have to add up the area under the curve in the lower tail and the upper tail. So here you can see how to use your calculator, TCDF, lower bound, upper bound, and I get a p-value of 0.137 approximately. But that's just the area in the lower tail. My total p-value in a two-tailed test is not just the lower tail, it's the lower tail area and the upper tailed area, which is a total of 2 times 0.137. So that's about 27.4%. Well, whether I'm at a 5% significance level or a 1% significance level, I need to fail to reject my hypothesis. You can only reject your hypothesis if the p-value is lower than alpha. It is not lower here. 27% is not lower than 5% or 1%.